Thunder is the sound caused by lightning. Depending on the distance and nature of the lightning, thunder can range from a sharp, loud crack to a long, low rumble. The sudden increase in pressure and temperature from lightning produces rapid expansion of the air surrounding and within a bolt of lightning. In turn, this expansion of air creates a sonic shock wave, similar to a sonic boom, which produces the sound of thunder, often referred to as a clap, crack, or peal of thunder. The distance of the lightning can be calculated by the listener based on the time interval from when the lightning is seen to when the sound is heard. Cause. The cause of thunder has been the subject of centuries of speculation and scientific inquiry. The first recorded theory is attributed to the Greek philosopher Aristotle in the 3rd century BC, and an early speculation was that it was caused by the collision of clouds. Subsequently, numerous other theories were proposed. By the mid-19th century, the accepted theory was that lightning produced a vacuum. In the 20th century, a consensus evolved that thunder must begin with a shock wave in the air due to the sudden thermal expansion of the plasma in the lightning channel. The temperature inside the lightning channel, measured by spectral analysis, varies during its 50-1/4s existence, rising sharply from an initial temperature of about 20,000 K to about 30,000 K, then dropping away gradually to about 10,000 K. The average is about 20,400 K. This heating causes it to expand outward, plowing into the surrounding cooler air at a speed faster than sound would travel in that cooler air. The outward moving pulse that results is a shock wave, similar in principle to the shock wave formed by an explosion, or at the front of a supersonic aircraft. Experimental studies of simulated lightning have produced results largely consistent with this model, though there is continued debate about the precise physical mechanisms of the process. Other causes have also been proposed, relying on electrodynamic effects of the massive current acting on the plasma in the bolt of lightning. The shock wave and thunder is sufficient to cause injury, such as internal contusion, to individuals nearby. Inversion thunder results when lightning strikes between cloud and ground occurred during a temperature inversion. In such an inversion, the air near the ground is cooler than the higher air. The sound energy is prevented from dispersing vertically as it would in a non-inversion and is thus concentrated in the near-ground layer. Inversions often occur when warm moist air passes above a cold front. The resulting thunder sound is significantly louder than it would be if heard at the same distance in a non-inversion condition. Etymology: the D in modern English thunder is epenthetic, and is now found as well in modern Dutch donder. In Latin the term was tenere to thunder. The name of the Germanic god Thor comes from the Old Norse word for thunder. The shared Proto-Indo-European root is tar-cubed-en-re-yen-or-tar, also found Gaulish Taranis and Hittite tar-hunt. Calculating distance, a flash of lightning, followed after some time by a rumble of thunder illustrates the fact that sound travels significantly slower than light. Using this difference, one can estimate how far away the bolt of lightning is by timing the interval between seeing the flash and hearing thunder. The speed of sound in dry air is approximately 343 ams or 1,127 feet per second or 768 mph at 20 degrees Celsius. This translates to 0.213 miles per second, or approximately 5 seconds per mile. However, this figure is only an approximation, as air is hardly dry in a thunderstorm. The speed of light is high enough that it can be taken as infinite in this calculation because of the relatively small distance involved. Therefore, the lightning is approximately 1 kilometer distant for every 3 seconds that elapse between the visible flash and the first sound of thunder. In the same 5 seconds, the light could have traveled the lunar distance 4 times. Thunder is seldom heard at distances over 20 kilometers. A very bright flash of lightning and an almost simultaneous sharp crack of thunder, a thunder crack, therefore indicates that the lightning strike was very near. See also, thunderstorm, thunderbolt, lightning, brontophobia, mist poofers, the castle thunder sound effect, list of thunder gods, Thursday, references. External links, media related to thunder at Wikimedia Commons, The Science of Thunder, Thunder, A Child of Lightning, Wikibooks, Engineering Acoustics Thunder Acoustics.